Hi, everyone. Welcome to our Asserts webinar on reducing alert fatigue with SLOs. SLOs are not just for reporting. I wanted to do a little bit of housekeeping here. So this webinar is being recorded. All participants are on mute. We'll have some Q&A at the end, and please enter your questions in the Q&A queue. So today, two speakers will be Steve Waterworth and myself, Jim Gehrett. Steve, would you like to introduce yourself?
Hi there. Yeah, I'm Steve Waterworth. I've been in the monitoring APM observability space for quite a while now with various different technology companies, starting with Wiley and AppDynamics and Instana, and now, of course, Asserts. I'll be doing a product demo later on in the webinar. Over to you, Jim.
Thanks, Steve. I'm Jim Gehrett, founding engineer with Asserts. I've been working with this team for several years at AppDynamics. Been in software engineering for a lot of years. Most of my career as an engineer, with a few stints as engineering manager. So let's see, about Asserts. We were founded in 2020. We came out of stealth earlier this year. I mentioned the team, a large team from AppDynamics and Instana are part of Asserts currently, including our founder was one of the founding engineers for AppDynamics. And we're backed by Andreessen Horowitz and Icon Ventures. So the problem area we're covering today is alert fatigue from too many false positives. So, you know, it's hard to always find the needle in the haystack of these alerts that we have firing in our systems. Excuse me. You have the constant toil of alert rule and dashboard maintenance. It takes forever to find the root cause when you've got too many alerts firing. And you end up being reactive and proactive. I know in my experience many times, the alerts you create and some of the dashboards you create are in response to an outage that occurred. So you end up having to react to this, try and catch the next time around. So that creates a very high signal to noise ratio with all these false positives. So you end up drinking from the fire hose, as they say, and so you get too many meaningless alerts. It really becomes impossible to see what's going on with all this happening. And with all those alerts firing, inevitably you're going to miss something that needs some immediate attention. So toward that results in constant toil and trying to deal with the alerts. And you have this Herculean task of trying to manage your rules and dashboards. And so to try and tame all those alerts firing all the time, you end up tweaking thresholds, too high, too low. You don't want to be woken up at 2 a.m. for things that don't really need attention. And then same thing with the dashboards. You want to make sure you get the right things in the dashboards, and some metrics change possibly and your dashboard stops working and you don't know until you've missed something. And then ultimately, sometimes your job ends up migrating to just being the manager of alert thresholds and dashboards rather than actually improving and managing your system. And that being said, though, alerts get created for some reason. You just may not want to get notified. So alerts just don't create themselves. You've built them for something. So here we have SLOs. They're not just for reporting. They also are key in helping you get good visibility and monitoring of your system. So that's why at Asserts, we want to operationalize SLOs. So you can identify, you know your system better than anyone. You know what's the critical parts of your system. So you can identify those SLOs and monitor them in real time. Payment system needs to respond in such and such time. And any number of things. When someone checks a balance, it's got to respond and whatever the threshold is. You know these things, you can set these things for sure. And you're allowed to dictate what it means to have a reliable system for your customer. So through these SLOs, you can choose to notify on those SLOs. So once you define an SLO, you'll have an error budget that you can stay within to not violate whatever you set your threshold to be. So we'll notify you then when there's a slow burn happening where it looks like you may violate your SLO. And also if there's a fast burn where it looks like for sure you're going to violate it. So you'll get those notifications and you won't get all the noise for all the other alerts firing. As I mentioned, alerts are created for a reason, so they should all be sent to Asserts, and we can take them all and collate them. And then when SLO does fire, you have all those other alerts that are in the system that you can now see correlated in a timeline as well as an entity graph.
Yeah, I should also point out there with the SLOs, as long as if you give them suitable names, then you get some context around what the alert is. It's not just that something's slow or there's an availability issue, but you know what part of your system is having that issue. So in our example there, we've got shipping latency. So we know that's the shipping service. What this means in a practical application is if you have multiple problems, you know straight away which piece of functionality has been impacted, and therefore you can prioritize. So if we carry on with our e-commerce analogy, if we had two alerts firing at the same time, one for the payment gateway and one for the wish list, both are important, you know, both are customer-facing services, but my money's on the payment service. That's the one that's transactional. It's making us money. The wish list, yeah, we're going to have customers that are upset, and we certainly want to fix it, but we want to jump on the payment problem first. So that's one of the big advantages of using this, is that you get not only notified only when there's a problem, but you get that context with it.
Absolutely. Couldn't have said that better. So towards that end, you can go from the SLO to a root cause. So Asserts understands the entity relationships between all the parts of your system by analyzing your metrics and the metric labels. So when you do see that SLO violation, as like in the previous screen, that'll take you directly into the RCA workbench, the root cause analysis workbench, with all the entities related to that SLO violation, as well as all the alerts that are happening at that point in time. So you can dig through those and see what's happening. First thing you think of is what changed, what was something deployed, so on and so forth. And you'll see all that stuff within the timeline. So you can see the timeline view as well as the spatial view of what's happening. And the graph and the metrics, of course, are historical also. So you could compare this with previous events potentially. And then you also have not only all those metrics available, you have the context of being able to drop into your logging or your tracing system with pre-filtered queries based on the time windows and different specific search criteria from the context that we have within Asserts.
Yeah, and also in presenting the entity relationship, it gives the operator a better understanding of the application and what's happening. So this means even junior members of the team who might not have guru level knowledge of the application and its environment, they're getting that additional context from seeing the relationships and knowing that this service depends on this other service, which in turn depends on something else. So that's really going to considerably aid that root cause analysis, because you can follow down that call link as the request hops from one service to another, which is of course especially true in microservices applications in a Kubernetes environment.
Exactly. A little bit about our architecture. We have a SaaS offering, if that serves you, and we also have Helm chart, so you can install directly into your Kubernetes environment. And we install, it's fairly lightweight installation. We don't require any agents on your services. We install our UI and backend services. We have an alert manager we install, a Grafana instance, as well as a TSDB. The Grafana instance will ship with some of our dashboards as well as community dashboards, and give you the ability to import your dashboards. And even so, once you import your dashboards, you can then link them to known entity types within Asserts. So as you're exploring and doing your root cause analysis and looking at different entities, you can also see your specific dashboards too that are related to those entity types. And as far as reading your metric data, so within Asserts, you just point us to your different Prometheus instances. You can include multiple, and we'll read from them. Again, nothing else installed in your system. The only thing is we'll have some additional reads against your Prometheus servers, and then we'll normalize some of those metrics into our metric model. That's why we have a TSDB, so we can use our dashboards for some of our different functionality. And yeah, and that's the installation, the architecture. It's fairly lightweight, and it doesn't install anything else into your system.
Yeah, the key thing there is that we're not replicating your entire Prometheus metric set. We're
Exactly.
querying your existing Prometheus servers for certain key metrics, which we then normalize and store in our own data store. So most of the time, Asserts is reading a cache from its local data store. It's not hammering your existing Prometheuses with a heavy load of queries.
Exactly. And with that, I will hand over to Steve for a demo.
Okay, thank you very much. Let me just quickly share my screen. So starting off, not in Asserts, but in Slack. And here we have a Slack channel, which probably looks very much like your Slack channel or email or whatever messaging system you're using. As you can see, there's just a constant stream of alerts, and it's very difficult from these individual alerts to really gather any intelligence on what's going on, what's important, what should I jump on immediately, what's just a bit of noise. It's so painful trying to figure this out, because what tends to happen is that it all gets ignored until the phone starts ringing and someone's complaining, which is not really the best way to manage a system. You want to be proactive, not reactive. So if we have a look now at the channel that comes directly from the Asserts via that SLO mechanism, and straight away here we have a typical alert, which is the SLO for the latency on our shipping service. So straight away I've got the context. I know that it's the shipping service that's been affected, or the shipping functionality. So all that functionality around that. As I said earlier, then that knowing that context allows you to prioritize what should I jump on first if multiple events are happening at the same time. But what we can do then from that event notification is just follow the deep link, and that will take me straight into Asserts and into the root cause analysis workbench. And because we have that map of the entity relationships, we know how everything's interconnected, so we can pull in all the relevant information around those connected services. So we take a look, for example, at the graph here. We see we've got our shipping service, and our shipping service is dependent on MySQL, but then so is this ratings service, and the shipping service also makes use of cart. So we've got our blast radius. So what Asserts has done is automatically pull in all that relevant information into one place. And now everything I need to do my root cause analysis and start piecing together the evidence to figure out what went wrong and how can I fix it, it's all here just a click away. So let's actually start that process of digging in and seeing what's happening. So we're on the timeline view, obviously time left to right, and then the different services below, and then any assertions or alerts that have been fired will pop up. So we've got some saturation, a few bits and pieces going on here. So we get a good overview, and that sort of gives us a good starting point. And I tend to prefer to jump into the summary view, which gives us a bit more detail. Still time-based, but with a little more detail in there. We can see all the individual assertions that fired. And if I mouse over anywhere, it shows that entity graph in the little pop-up window. So again, it's going to help with that understanding of what's talking to what and how different services are going to affect one another. So as we can see, our shipping service really makes use of MySQL. We know that the alert is against shipping. So, and it was on a latency. So we have this latency build up here. If I open that up, I'll just minimize this window, give myself some more screen real estate. So we can see then our latency had a big spike. And you can see here, this is the calculated normal. So everything, all these key metrics are baselined. So that means I'm no longer manually tweaking and setting thresholds to try and get the right thresholds so that I get alerted when I needed to be alerted and not blasted. Or if I set it too high, of course, I might miss something. So that automatic baseline really takes all that toil of maintaining thresholds. So we've got our alert there on the threshold, and we can see, well, what else is happening at around the same time? Well, we've got this garbage collection going on. So again, we see a big spike in garbage collections, and that's interesting. So that's starting to give us a steer on what the problem might be. So let's say I want to take a little deeper look around what's happening with the garbage collection. Well, I can jump straight into the Grafana dashboards. So this loads up the Grafana dashboard associated with this technology type. So we see the service metrics, but I'm interested in the JVM metrics. As we've already mentioned, this is Grafana. If you've got your favorite Grafana dashboards you want to pull in, they can be imported into here. And if you tag them appropriately, they're going to appear in this list of available dashboards. So drilling into the JVM specific metrics and looking at our garbage collection performance, then you can see, yes, we're having a whole bunch of stop the world garbage collections around the time of our problem. So that's all starting to make a bit of sense, because of course, if our JVM is doing big garbage collections, it's not doing anything else. So hence why all these other endpoints also are slow. So I'll just squeeze those up. And also interestingly, we've got a big spike in network traffic. So, okay, that's giving us a bit of a steer. So what's it talking to? Why is there a big spike in network traffic? Well, we know from the pop-up graph that shipping is dependent on MySQL, and here's our MySQL process. And it also has a big spike in network traffic in transmit. And it's also got some saturation warnings around CPU utilization. And we can see here that the container's been throttled. It's trying to use more CPU than it's allowed and is hence being throttled. So that's slowing down MySQL. So that's starting to give us a bit of a clue either that MySQL is working very hard. It's using a lot of CPU. It's transmitting a lot of data. Also, the buffer pull requests are also a lot higher as well. So it's shifting a lot of data. So, okay. We go back to our shipping service. What else can we see that is a problem here? Well, we see, oh, interesting. There's an error log here. So this is then the number of messages being written to the logs at error level. There's also a big spike. So that's good. So we're logging something that might be informative. We might be logging some error messages. So let's go take a look at the logs. So again, I can go one click in context to my current logging system, which in our demo system is Loki, but we hook into all the popular different log aggregation systems. If I expand one of these log lines out, you can see we've got a slow query log, 5 and a bit seconds for this particular query, and this is the query here. So we know what the query is. Fortunately, a useful logging message has been written. So we're really pulling together a good picture now of what's happening. It looks like we've got a particularly bad query that is pulling a lot of data, hence heavily loading the MySQL and the amount of network traffic. Because the results of that query get loaded into memory, hence the high garbage collection and the pressure there and the stop the world garbage collections. So if we hop back to our workbench, and then really, this is the giveaway. I deliberately left it to the end. We've all got a change notification here. And if we look at this, we can see we went from 103 of our container to version 104. So yeah, change is good, but this one wasn't. So it looks like we've got with that new release came a change in the query, and the query just doesn't perform. And of course, we rolled that change back later and all the problems went away. So it's probably something like it worked fine in test on a small data set, got deployed into production on the full production data set, and the query returned way more data than it did in test, and it blows up. So that's very quickly then from that notification of having a problem with a particular service to getting to that root cause and getting that fix out. So if we carry on, and this looks, now we've sort of gone through that scenario, we carry on and have a look at a few other things. So we've been talking about SLOs. Let me clear this workbench out and we'll go take a look at the SLO list. And if you remember, we were looking at shipping latency. So for each SLO, you get a report that looks something along these lines. So the dotted line is the burn budget, and then the solid line is the actual burn. So whilst we're just by the skin of the teeth maintaining our SLO, so we haven't violated the SLO, but you can see over the history, there's been a number of accelerated burns, and this is the trigger for the alert. So of course, if we trigger, we would trigger crossing the line, but if we only triggered when you cross the line, that's a bit late. That is really shutting the door after the horse has bolted. You want to be notified when you're in danger of breaching the SLO, hence the sort of the edge detection here. And you can go directly from this report back into the root cause workbench again. So let's just have a little look at our entity graph. So these are all the services that make up our little demo application and their relationships. And this, the relationship map is all built by analyzing the metric labels. So we can use the data from those metric labels, do some analysis on that, and infer the relationship of everything. And there's other drill downs we can do from here. We can go take a look at the pod associated with that particular service. So there's various different ways and means of looking at this. And this also comes in quite handy if I filter this list by assertions. So the thing with the most assertions is at the top, which is of course shipping, because we're still in that time range. So let's have a look, say like the last 12 hours. We might get a slightly different view of the world. So really anything then with a bit of a color on it is something that is potentially having some issues. So what I can do is just add one of those. Let's clear that out and do that again, is add that service to my workbench, then I can go investigate it. So this is the other use case. Obviously we want to respond to alerts when they happen, but a good system reliability engineer should be keeping an eye on the system, looking at ways we could tweak and tune the system to make it more efficient. So we can see that catalog has some latency issues on it, but there don't seem to be doesn't seem to be a particular pattern to them. It's just one of those sort of little random things it's doing every now and then, just a little statistical blip. So in a traditional system, because you'd be getting an alert every time this happens, and you'd be like, oh, is this really important? Is it really dragging down the user experience? Do I need to jump on this and fix it? Or is it something that's possibly just needs tweaking and tuning later? So because we're using that SLO mechanism, these little sporadic problems that it might be having, they're not impacting an SLO, so we're not generating an external alert, but the events are still recorded. We still know that they happened, and we can do some analysis on that. And again, we could dig deeper. We could go to the dashboards associated with that. And we get our request history here, you know, our core metrics, rate, errors, duration that's going on. And again, this is Node.js. So we have our Node.js data around here and our event loop latency, which is probably the major thing for Node.js. And yeah, no real problems there. These occasional little spikes, and maybe something that could be tweaked and tuned to improve it. But that's something that can be done as and when it's not impacting an SLO. So that pretty much sums up the demo for now. I think we'll go back and we'll take a look at the Q&A.
Yeah,
Did we get any questions coming in?
Yeah, thank you very much, Steve and Jim. So we have a couple of questions here, and we have about 10 minutes or so left to kind of discuss them. So I won't ask them of a specific person. So either of you feel free to jump in, or both of you can discuss the questions here, just a couple of them. So you showed the entity graph. How are those relationships figured out? Do you have a tracing kind of underlying the system?
No, it's not done with tracing. It's all metric based. We do integrate with tracing systems if you have gone that far. But yeah, it's all this relationship data comes by analyzing the metric labels. So, for example, if you're using a service mesh such as Istio or Linkerd, it's outputting Prometheus metrics. So we can analyze the labels of that. We do have in development our own eBPF agent, which again figures out how things are connected and outputs Prometheus metrics. And then ultimately there is a fallback of some manual configuration where you can tell it the mapping yourself. So there's various ways and means of getting all that information in there and inferring the relationships between the services. Obviously, relationships for things like pods to namespace, services to pods, all that type of thing. That's all. We get that basically from kubestate metrics, which is a standard Prometheus metrics collector in a Kubernetes environment.
Yeah, and for filling the gaps for any missing relations, it's very simple to do. You can see on the bottom of the screen there's a relations button where you can just graphically connect between entities.
Cool. All right, so the next question is a two-part question. It says, do I have to have an SLO on everything? And then second part to that, how do you actually define SLOs in the system?
Well, no, you don't have to have an SLO on everything. In fact, it would be a bad idea to have an SLO on everything, because you could just end up out of the frying pan and into the fire.
Right.
The key idea here is to have SLOs on things that are important, not necessarily every little component of the system. So think about the things really that are user facing, that if it started to misbehave, somebody would notice. That's the key, to have the SLOs on that. And you can create SLOs on all sorts of things, so you can group things together. The SLO doesn't have to be just on a single service. It could be on a collection of services. There's various different ways of doing that. And the SLOs are actually defined, well, a couple of ways of doing it. You can do it through the UI, but there's also a custom resource definition for doing SLOs if you want to manage your SLOs as code. But we can add an SLO via this dialog. I'm not going to go all the way through it, but basically give it a useful and informative name. And then at the top level here, we can select the service we want it on, the type of request, and then optionally filter even more by context, and then we specify the duration, so like last 7 days, and then we can start putting in the objective. So we could call this weekly, And that's a 7. And then, what we're aiming for, 99%, for example. And you can have multiple objectives against one SLO. So you could have a weekly, a monthly, daily, however you want to do that.
And it's also important to note too, for all those alerts that are firing, you can choose to be notified for any one of those. You see them as you're going through the UI, and where Steve was showing earlier, you can right click on them and choose to be notified for those. So you don't have to have an SLO for a notification. You can still choose to be notified on a specific alert that may be important to you.
Yeah, that's true. Everybody's system is unique, and there may be certain key indicators in your environment that, I say like a queue depth. If this queue depth gets above 5, oh dear, something's gone horribly wrong. This is really important. We really want to know about that. You wouldn't build an SLO on that. You would just create an alert straight off that key metric.
Mm-hmm.
All right, and I have one final question here. Can I use my existing Grafana dashboards, or only the ones that come out of the box?
No, you can use your existing ones. We
sure.
provide a curated library of Grafana dashboards. So all the sort of standard technology dashboards, you don't need to worry about managing and maintaining anymore. They're part of the product. But of course, you may have some favorite little pet dashboards that give you a great insight into your environment. Yeah, you can certainly import those. We're just using standard Grafana. And if you tag them correctly, then they will appear in context as you navigate around.
Exactly.
All right, so there's no more questions. Any final thoughts from either of you, Steve or Jem?
I wish I had something like this over the course of my career. That's for sure. I've got a lot of scenarios, a lot of lost sleep that I would have got back. That's for sure. And it's been exciting to build this, and I'm really excited for this product.
Yeah, I mean, the great thing about Asserts is that we're using what you've already got. You've already got your Prometheus metrics in there. You've got this vast pool of metric data, but you're not really getting any information out of it. So we're really adding a layer of intelligence on top of what you've already got, which makes your life a lot easier.
Yeah, and not having to manage thresholds and all those different things that just become such a headache is really convenient. And as more technologies come online, more and more exposing Prometheus metrics, so we'll just be able to consume more and more.
Perfect. Well, thank you both for presenting today. Thank you for all the attendees for attending. The recording will be sent out to everybody after this call, so please feel free to send it and share it with anyone who you think might find some use from it. And that concludes our webinar for today. Have a nice day, everyone.
Thanks, everyone.
Thanks, everybody.